A survey was done among 8 learners on their favorite sport. The results are shown below. So 52 learners liked rugby, 42 learners liked volleyball, and 5 learners liked chess only. Right? Then 14 learners liked rugby and volleyball, but not chess. Then 12 learners liked rugby and chess, but not volleyball. And then 15 learners liked volleyball and chess, but not rugby. Now, it's important for you to know that this word but here, okay, the word but here is very, very important in probability. Also, the word only is also important. Okay? Then X learners like all 3 types of sport. Then it says 3 learners did not like any sport. Now, it's important for you that to know that when you are drawing a Venn diagram, first you must look at what's common for all 3 events. So in this question, X learners are common to all 3. Okay? X learners are common to all 3. So if you go to the Venn diagram, right? I know you've seen the Venn diagram, but I'm going to go over it, how I constructed it. Okay? The key thing is how to construct it. So those X learners, I put them there. Okay? Because the question says X learners liked all 3 sports. Then we need to move on to those learners who like 2 sports. Okay? But they don't like the 3rd one. Okay? They only like 2 sports. So we have 14 learners who like rugby and volleyball, but not chess. They don't play chess. They only play rugby and volleyball. So those 14, we have they like rugby and volleyball, but not chess. So we put them there. Because the question is very specific. It says 14 learners like rugby and volleyball, but not chess. So we put them at the intersection of rugby and volleyball. Alright? Then we have 12 learners who like rugby and chess, but not volleyball. So those 12, they play rugby, but they don't like to play volleyball, but they like chess. So rugby and chess, those 12, we put them there. They don't play volleyball at all. They like their rugby and they like to play chess. Then we have 15 learners who like volleyball and chess, but they don't like rugby. So the 15 who like to play chess and they like to play volleyball are going to be those 15. Are you following? Huh? Right? Then the next thing that we also have to consider now is we have these 3 learners who did not like any sport. So we put them outside the 3 events. So we put those 3 there. Okay? It's possible that some people may not like rugby. Rugby is a very challenging sport. It's the only sport, contact sport, okay, in this country that I salute. Right? Okay. So, and then now we need to now determine those. Okay, we need to determine those who don't play. Who only play 1 sport only. They don't play 2. They don't play 3. They only play 1. So we are told here that 5 learners like chess only. 5 learners like chess only. So those 5, we will put them there. They play chess. They don't play rugby. They don't play volleyball. Now we need to determine how many play rugby only and those who play volleyball only. Now to determine them, we go to the total of all the learners who like rugby. It's 52. Okay? It's 52. So we need to subtract those who play rugby and chess, those who play all 3, and those who play rugby and volleyball. So it will be 52 minus 14 minus 12 minus x, which is what I wrote here. Now, if you add 14 plus 12, you get 26. Okay, so the sum of 26 plus x, we subtract it from the total of all learners who like to play rugby, which is 52. So it will be 52 minus 26 minus x, you end up getting 26 minus x. Okay, so these 26 minus x, they like to play rugby only. Alright, then it says 42 learners like volleyball, so we have to subtract these 15 plus those x plus these 14 as well. So if you add 14 plus 15, you get 29. 29 plus x, you subtract from 42, you get 13 minus x. This is just basic algebra. Okay, actually it's grade 9 or grade 8. So you get 13 minus x. Right? So that's how you construct the Venn diagram. Are you following? Huh? So it's important for you to know how to construct the Venn diagram. The key thing, if you are constructing it, look for elements that are common to all three first. Then you consider elements that are common to two events, then one event. Also look at what's not common, what is not part of any of the three events. Yes.
One question. So, like, how here there's rugby, volleyball, and the sports. Will there ever be a case where you say that you have to do a Venn diagram and there's only two sports that are like same size, and then one sport is
Okay, it might be possible, but when you are dealing with three events, you might want to know what's common for all three as well. Yeah. So generally, most of the questions based on your curriculum, they will have some kind of intersection of all three, like this x here. Okay, you won't get a question whereby two of them have got an intersection, then the third one does not have any relationship with the other two. All right. Right. Can you please do me a favor? Right, is there anyone who has got another question? Okay, you don't have a question? Okay, let's solve for x now. Remember what the question was asking. It says show that x is equal to 8. But you can't show that x is equal to 8 without the correct Venn diagram. You need to have the correct Venn diagram. Alright? So, I now need to show. So we have a total of 80. So I'm going to write my equation. Okay, let me do it on the next page. So my equation is going to be 80 is equal to now I just have to add everything, including these three here. Okay? So I'll start by the 26 minus x. 26 minus x plus 12 plus x plus 14 plus 13 minus x plus 15 plus 5 plus 3. Okay? Remember, we are already told that x is 8. We just have to show that it is really equal to 8. So if you use your knowledge of basic algebra, this minus x and that positive x, they cancel out. Okay? So end up having on the right hand side 26 plus 12, which is 38, plus 14, that's 52. 52 plus 13, that's 65, plus 5, that's 70, then there was 75, and then you have got, I think I found it. Okay, wait. 88. Okay, you do what? 88. So 26, that's 38, 52, 65. 65 here, then you have got 20, that's 85 plus 3, which will give me 88. Right, so I'm smiling now because my answer is going to come out. So it will be 88 minus x. Remember, I told that in probability, when you are doing questions on the Venn diagram, no negative answers. You can't get a negative answer. Then you check the minus x to the left, you get 88 minus 80, and this will give you 8. So indeed, x is equal to 8. So I have shown here that x is indeed equal to 8. Are you following? But if you attempted the question on your own, just mark your work and do some corrections. Please, let me warn you, because some of you like to be serious after writing a test. Right? This is the moment for you to be serious. Your probability, you don't know which question they will bring in your trials, in your final exam. They may bring a Venn diagram, so you need to be ready. I'm going to introduce the tree diagram just now when I finish this. Then you also have what's called a contingence table, right? That's all grade 11. So normally there will be a question from grade 11, okay, on probability, then the grade 12. Okay, so now that we know that x is equal to 8, let's go back to our Venn diagram and find out by substituting where there is x. So if I put 8 here, I'll get 18. Can you stop talking? So here we have got 8, and then 13 minus x, 13 minus 8, that will give me a 5. Okay. Normally, you should do this. You should draw a second Venn diagram where you substitute the value for x, and then you can have your Venn diagram with integer values throughout. Okay? You're supposed to draw a second one. Alright, now let's answer the questions. The first question says, how many learners like only rugby? Well, I can write the answer straight away here. Those who like rugby only is going to be what? 18. So the answer here, it will be 18. Now, check this. If I use the correct notation for this, it will be NR. Okay? NR will be equal to 18. That's the correct probability notation. Okay? Then 9.4 says, calculate the probability that a learner chosen at random likes at least 2 different types of sport. Okay? This word at least, it means that's the minimum. So a learner will like 2 sports, or they like what? 3 sports. They won't like one only. Okay? So we go to the intersections. All the intersections, that's where you will get your answers. So we add the 12, the 18, which is the same as the x, the 14, the 15, and the 5. Then we divide them. We divide that by the total in the sample space. Now allow me to change my notation which I used at the beginning when I introduced grade 10. Remember, I told you that the probability of any event is equal to NF. I was trying to make it a little bit easier for you over NS, right? Where F, I said, is the number of favorable outcomes. Now, generally, when you write this formula here, whatever letter you put here is the same that you're supposed to put there. Okay? So I'm going to change here where I put F here. I'm going to put the correct event, which is on the left-hand side. I only did that when it was your first time to do this topic. If it was a proper grade 10 class, I would start from scratch on everything. But at least now you've got some kind of background. So whatever event is on the left-hand side in the brackets, you put it in the brackets in the numerator as well. Okay, so let's move on. So here, so we are doing 9 point, remember it's now 9.4. 9.3, I answered next to the question. So first, we know that our total in our sample space is 80. Okay? Then we need to know what is the total of liking at least 2 sports and at least 2 sports. That's our event. So this will be equal to, so we go and you then have to add, so it will be 14 plus 12 plus 8 plus 15 plus 5. Okay? So this will be equal to 14 plus 12. Okay, so it's a mistake. Not 5. 14 plus 12 plus 8. Okay. So it's 14 plus 12 plus 8 plus 15. Okay. Plus 15. You add this will give me 20. That will be 35 plus 14. Now get what? 49. So here, the probability of getting at least, or rather of doing at least 2 spots, it will be equal to 49 divided by 80. Okay? Now, you can't simplify that at all, because there's no common factor between 49 and 80. And there is no need to convert it to a decimal. So you leave your answer like this. There's no need to okay, there's no need. You're wasting time, because you convert that to a percentage, and they are called equivalent fractions, remember. So you've got a common fraction, you've got a percentage, you also have a decimal. They are equivalent. Okay, so if you write your answer as a common fraction like that, if it can't be simplified, just stop there. What's important is your denominator must be the total in the sample space. Your numerator must always be less than the denominator. Is that clear to everyone? Yeah, because very soon you are going to, when you write your trials, you are going to see a question. Last question it will be on probability. You can't write a numerator which is more than the denominator. That's a big no in probability. Okay, any questions? All right, so what I'm going to do